Okay, hi, what I've got here is a problem. Here's the picture of the function. And I want to talk about now doing a horizontal and vertical shrinking or stretching at the same exact time here. So what I want to note here is I've got these coordinate pairs over here. And these coordinate pairs are -2, 0, 0, 3, 2, -1, and 6, 0. And those correspond with the points that I have here. Okay, and I have them labeled out for a reason. I've got this function here. It says y equals f of x, and I'm just saying that that's whatever that equation is. And now I want to look at what would the graph look like if I multiplied the function by 3 and I had a doubling of my input. Okay, so what I want to talk about here is that I last two videos talked about stretching horizontally and stretching vertically. I'm just now doing the same exact thing, except I'm just going to keep my coordinate pairs together. So what this implies here is that I'm going to be multiplying the y by 3 and I'm going to be setting up my x equal to 2x. So what I have here is that for this particular point, -2, 0, what I now come up with is that I'm going to say, okay, well 3 times 0 is now going to be my new y coordinate. Well, 3 times 0 is 3. And then I make up the equation where I have 2x is going to be equal to -2. So 2x equals -2. So I get my new x coordinate is -1. So now my new point for this, -2, 0, is actually going to be, that's a 0, sorry, is going to be -1, 0. So I now have a new coordinate pair. And then I just plot it. So -1, 0. So there it is. Okay? I then go to my next point and I do the same exact thing. So 3 times the y coordinate, which is 3, because this is telling me to take a multiple of 3 of the output. So 3 times 3 is now equal to 9. And then I do the same exact thing where I say 2x equals 0. Well, 2 times any number that gives you 0, it has to be 0. So my new coordinate pair is 0, 9. So now I go to 0. I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I plot my point. Okay? And then I come down to here and I now have 3 times -1, which is -3. And I do 2x is equal to 2. Well, 2 times what number gives you 2? Well, it's 1. So now my new coordinate pair is 1, -3. So I go to 1, and I go down 1, 2, 3. Okay? And then I do the same thing for 6 and 0. Well, 3 times 0 is still 0, so my output is still 0. And my x coordinate is 2 times what gives you 6? Well, 2 times what gives you 6? Well, 3. So 6 divided by 2 is 3. So now my new ordered pair here is 3, 0. So when I go over to is 3, I go to 0. Okay? So now all I got to do is plot my points. So plot them. So here it comes. And then I'm done. And what I want you to note here is that when I drew this in, okay, I want to talk about the things that are occurring here. Okay? As this number inside here got larger, it actually took my points and it scrunched them in. Okay? So there was a vertical shrinkage along the x-axis. As this value was larger, it actually made them go farther. Okay? It actually pushed them, stretched them out along the y-axis. And that's the important thing to remember here again. Okay? So this is horizontal and vertical stretching at the same exact time. If I would have put a +1 here, all I would have done is moved all these values up 1. Up 1, up 1, up 1, up 1. Okay? If I would have put a -1 in here, now that would change it a little bit different because you have to go through and actually do the rules that apply with it. But currently for this one, this is the stretching and shrinking problem done together. You're going to each individual point and you're implying the vertical to the y and you are implying whatever's on the inside to the x. And then you do them both at the same time to that coordinate pair, and then whatever you get for those two particular values is your new coordinate pair. So I hope that helps with any type of vertical or stretching problems that you might have that involve multiple things.